the tiny regulator with global power, the ISA. Unknown to most people on land, there's a small office in Kingston, Jamaica, with a mandate that stretches across nearly half the planet. The International Seabed Authority, 169 member states, a few floors of meeting rooms, and a job that sounds impossible: regulate mining in the part of the ocean that belongs to no single country. Under the law of the sea, that seabed is the common heritage of humankind. The ISA is supposed to make sure it stays that way. Benefits shared, science supported, environment protected. Here's the twist. The ISA also has to enable extraction. It writes the rules that could let machines roll across abyssal plains. It awards exploration contracts, 31 by mid-2022, covering more than 1.5 million square kilometers, and it's drafting the mining code that would govern exploitation. It's a split personality baked into law: open the door and guard it. 3 years earlier, something unusual happened. In June 2021, Nauru, sponsoring a contractor tied to the metals company, pulled a lever in the treaty called the 2-year rule. It told the council, finish the regulations in 2 years because we intend to apply to mine. The intent was clear: create a clock, force a decision. Staff scrambled, committees formed, red lines multiplied. The deadline passed in July 2023 with no final rulebook. But the pressure worked. Negotiations accelerated. The council aimed to wrap in 2025 if the text was ready. Companies told investors they were ready too. From the outside, it looked like a technical debate: royalty rates, environmental baselines, plume thresholds. Inside the room, delegates were juggling more than clauses. Small island states were thinking about tuna, tourism, and sovereignty. European countries weighed green industrial ambitions against public opposition. Nations with contractors wanted certainty. Others wanted time. Scientists kept reminding everyone that the deep sea remains poorly understood, that impacts could be permanent, that baseline data is thin. Meanwhile, something else was happening. A chorus was growing for a moratorium or precautionary pause. It wasn't just NGOs anymore. Governments from the Pacific and beyond stood up in council sessions and said, "We're not ready." The IUCN had already called for a halt unless strict conditions were met: comprehensive risk understanding, transparent assessments, polluter pays, circular economy first. That language filtered into national position. And then, far from Kingston, bans appeared. Australia's Northern Territory, multiple US states. Canada's Fisheries Act kept domestic waters off limits. The ISA felt like a pressure cooker with vents opening elsewhere. To understand the ISA, you follow the incentives. Contractors need clarity to secure financing. Sponsor states, often small, sometimes economically stressed, see a pathway to revenue and influence. Larger powers see supply chains and strategic metals. The Secretariat has to shepherd a process that keeps all sides at the table. And hanging over everything is a legal principle that sounds noble and is hard to implement. The common heritage must benefit all humanity. How do you quantify all when the impacts are local and the metals go to factories far away? What nobody in those negotiating rooms could ignore was the optics of speed. The trigger created an artificial deadline. It also created suspicion. Was the clock about science or share prices? When a contractor suggested it might pursue a national permit elsewhere, bypassing the ISA, the Secretary General called it a violation of international law. That flare-up told you how brittle the consensus was. If the authority splinters, the whole promise of a shared seabed collapses into a race. At the same time, the ISA really is tiny for what it's tasked to do. A handful of technical staff must review complex environmental plans, run compliance, and referee an industry that can outspend them on consultants. Delegates rotate. Knowledge walks out with elections. The Legal and Technical Commission, charged with reviewing applications, meets behind closed doors. Transparency advocates argue that's untenable for public trust. Contractors argue proprietary data needs protection. That tension shows up in every draft paragraph. From the perspective of Pacific communities, the power dynamics are stark. A map drawn in Kingston can overlap with livelihoods in Kiribati, Tonga, and the Cook Islands. A sediment plume modeled on a slide could drift across migration routes that pay for nurses and textbooks. If things go wrong, who is liable? How do you prove harm 4,000 meters down? The liability chapter of the mining code remains one of the hardest knots. Without it, effective protection is a promise without teeth. And yet, the ISA is also where caution can win. In marathon sessions, delegates have inserted stronger environmental language, debated adaptive management, demanded robust baselines, and acknowledged knowledge gaps. The Council has not rubber-stamped exploitation. The Assembly has heard loudly the case for a pause. If you strip away the corporate decks and the activist banners, you're left with a real question in a small building. Can a global regulator resist manufactured urgency and force industry to meet the highest bar before moving? Back in the CCZ, collectors keep crawling in tests, cameras roll, and the snow keeps falling through the water column. In Kingston, pens hover over brackets. The ISA was designed to balance promise and protection. What it decides next will tell us which word mattered more. The players, countries, corporations, and billionaires. While delegates argue commas in Kingston, the real momentum comes from people with balance sheets and election calendars. Start with the sponsor states. Nauru, Tonga, and Kiribati are small on the map, but central to this story. Each sponsors a contractor tied to the metals company, a Canadian-founded firm promising to turn potato-sized rocks into climate salvation and national revenue. For leaders managing narrow budgets and climate threats, sponsorship fees and a slice of future royalties look like a bridge. Yet at home, church coalitions, fishers, and elders warn that a bad bet at 4,000 meters could undercut tuna and tourism for generations. That tension, cash now versus ocean forever, sits in every cabinet meeting. Then there are the Cook Islands, rich in nodules inside their own EEZ and eager to define responsible seabed activities on their terms. They've issued exploration licenses, pitched rigorous oversight, and faced the same divide: economic sovereignty on one side, precaution on the other. Across the Tasman, Australia's Northern Territory took the opposite path, banned seabed mining outright, after a 9-year campaign led by traditional owners, fishers, tourism operators, and scientists. That decision echoes in Pacific capitals. If a wealthy jurisdiction says the risk isn't worth it, why should island states carry it? Meanwhile, Canada plays a split role. Its Fisheries Act effectively blocks deep-sea mining domestically because of harmful discharge risks, but Canadian-linked companies were first movers abroad. Nautilus Minerals tried to launch the Solwara 1 project off Papua New Guinea, promising jobs and minimal impact. It collapsed in debt and lawsuits, leaving coastal communities with no benefit and a sour lesson: the social license is the mine. That failure didn't end the pitch, it refined it. New deck stress, lower impact, metals from nodules, and cleaner supply chains. The label changed. The underlying incentives stayed the same. Corporate names rotate, but the model repeats. Global Sea Mineral Resources out of Belgium tested the Patania II collector and told the world impacts were manageable. Their data comes from narrow corridors in a vast, variable system, and it travels with NDAs. The metals company tells investors it will deliver nickel, cobalt, and manganese at scale, with lower carbon intensity than rainforest mining. Their critics ask about plume spread, mid-water discharge, and baseline data gaps. Both agree on one thing: the ISA must move. One needs rules to raise money. The other needs time to keep asking hard questions. Hover over all of this, and you find the battery economy. Car makers and electronics giants don't want headlines about child labor in cobalt or rivers turned yellow by laterite nickel. They want responsible sourcing badges that hold up under scrutiny. Some back recycling plants and traceability schemes. Others watch seabed metals as a potential hedge. The irony is sharp. The more investors worry about terrestrial abuses, the more compelling the ocean looks, if you accept a narrow frame that counts trees and ignores abyssal life. But there's another current: chemistry and circularity. Battery makers are shifting into nickel-light or nickel-free chemistries for segments that don't need long range. Sodium-ion, cheap, safe, and unburdened by cobalt, has moved from labs into early factories, especially for grid storage and short-range mobility. At the same time, recycling is scaling, with commercial plants recovering high shares of nickel and cobalt from scrap and end-of-life packs. None of this erases raw material demand, but it does bend the curve. Every percentage point of recycled content, every chemistry that skips cobalt, chips away at the argument that the CCZ must be open tomorrow. Now add the billionaire factor, not as cartoon villains, but as amplifiers. Venture funds chase narratives with steep curves, first mover advantage, trillion-dollar TAMs, SPAC pathways. A company that can claim exclusive access to a new resource class, metals for the energy transition lying untapped on the seafloor, fits the slide. The clock starts at listing, not at science. Quarterly calls don't wait for ecosystem baseline. When timelines slip, pressure leaks into policy. Urge the ISA to finalize, hint at national workarounds, frame delays as threats to climate goals. It's not an evil plan, it's how finance behaves when promises face friction. On the other side, philanthropy-backed ocean groups build coalitions that look soft until they land. Pacific civil society links hands with European ministers and US states passing bans. Scientists publish on midwater food webs and tuna overlap with mining contracts. A phrase, precautionary pause, moves from NGO memos into national statements. Suddenly, the inevitable industry looks conditional. The hallways in Kingston feel that shift. And yet, the biggest player might be climate itself. As the Pacific warms, tuna move east, pushing the economic center of gravity across lines drawn for mining exploration. If sediment plumes and noise meet stressed stocks and shifting spawning grounds, losses won't show up on mining P and LS, they'll show up in missing access fees that fund Pacific schools and clinics. Which makes the real choice clearer. Who carries the risk when two ocean industries collide? Strip away the logos and here's the cast. Small nations with everything at stake, corporations with machines in the water and investors at their backs, regulators with thin capacity and a heavy mandate, and a global audience that wants clean tech without dirty secrets. Each believes they're acting rationally. The question is whether their combined rationality adds up to wisdom, or to a plume nobody can stop once the pumps switch on. How you mine an abyss? Machines, plumes, and noise. To pull metal out of a place where sunlight never arrives, you start with a crawler. Think industrial Roomba scaled to a small house, armored against pressure, tracked like a tank. It inches across the abyssal plain, a front-end mouth scooping polymetallic nodules and the thin skin of sediment around them. Rotors churn, sieves rattle, pumps breathe. Everything the machine swallows mixes with seawater into slurry. That's the point. What nodules don't give up in speed, engineers reclaim in volume. The crawler isn't alone. Above it, a riser pipe as wide as a man's torso snakes 4,000 meters up to a ship. High-pressure pumps staged along the pipe lift the slurry like an elevator made of water and grit. The ship, a factory in waves, separates nodules from mud, stockpiles rock for transshipment, and here's the part the sails decks blur, discharges processed water back into the ocean. Not at the surface. That would create an obvious slick and clog intakes. The plan is to send it back down into the midwater twilight, dense enough to sink, distant enough to hide. Meanwhile, sensors blink constantly. The machine's weight crushes centimeters into a seafloor that's taken millennia to stabilize. As it crawls, a sediment plume blooms behind it, fine particles buoyed by the smallest turbulence. It looks like a fog bank in slow motion. In lab tanks, plumes settle in minutes. In the deep, with currents you can't see and particles you barely can, they can drift for kilometers, maybe hundreds, resuspending when eddies pass. Filter feeders, sponges, brittle stars, corals don't choke immediately. They clog, they starve, they stop reproducing. Now add the midwater discharge. That plume is different, colder, denser, loaded with tiny particles and trace metals, expelled under pressure into a zone crowded with life we rarely film, zooplankton, micronectin, small squid, lanternfish. These animals are the elevator of life, rising at night to feed and sinking by day, hauling carbon downward in a quiet rain. Replace their food with silt and metal-laced fines, and you don't just irritate them, you tilt a food web. A recent trial in the CCZ showed exactly that risk. Discharge can disrupt midwater food webs where the ocean's base calories are made and traded. Noise rides shotgun. The crawler hums and grinds. The pumps thrum like engines heard through walls. The ship adds its constant mechanical heartbeat. Sound moves differently under pressure. Low frequencies travel far. What starts as industrial noise becomes a curtain laid across a territory where whales navigate, squid communicate with subtle movements, and fish school by sensing vibration. Deep-sea creatures evolved in near silence, punctuated by the occasional crack or song. Continuous machine tone is new. You won't see it on an impact map. You'll hear it if you're a whale migrating across the line where contracts begin. Here, where engineering pride meets ecological math. Contractors say they'll minimize plumes with skirts around intakes, tune discharge to currents, and cap noise with dampers. Some measures will help, but the physics doesn't bend to promises. Scraping releases sediment, Pumping creates turbulence, separating slurry creates waste, and scale multiplies everything. A single test track might look tidy. A commercial field with multiple collectors operating around the clock for months turns tidy into weather. Sheets and billows of fine material moving beyond the light cones of any camera a company can afford to drop. Follow the path of what's taken. Nodules go to deck, then to barges, then to smelters on land because there's no refinery at sea. The ship keeps the crawler fed with power sent down the riser and instructions sent through fiber and acoustic links. When the crawler stalls on an unseen rock, the operator leans forward in a dark room a hemisphere away and eases the machine free. When the slurry thickens, pumps strain and alarms chirp. This is mining by latency, where the site is remote but the urgency feels close. Another reason timelines press and shortcuts tempt. Meanwhile, look at what's left behind. The track isn't just a path, it's a strip mine etched into silt. Everything that used the nodules as anchor points loses purchase. Eggs laid on hard surfaces lift into the plume. Microbial mats that tune to the chemistry of nodule skins disperse with no place to return. Recovery, where it happens, follows geologic time, not human time. If you're measuring quarterly, a year looks like a breath. If you're measuring the return of a habitat, a century looks like a hope. Engineers talk about adaptive management, monitor, adjust, reduce. That makes sense when you can see cause and effect quickly. In the deep sea, feedback is delayed and diffuse. If a plume suppresses feeding at 800 meters, the signal might appear as a shift in fish growth rates a basin away next season. If noise scrambles cetacean routes, strandings might rise on a coast that never heard of the CCZ. The accountability loop stretches until it breaks, and still the machine moves. Operators tick through checklists, pumps recover. The ship's discharge valves open again with a hiss. The abyss takes another breath of silt. Above, a school of tuna chases lanternfish that didn't rise tonight. Unknown to them across town, Kingston, the wording for acceptable plume is still in brackets. What lives down there? Unknown worlds, known risks. To grasp what the crawler drags through, you start with a light and a minute of patience. The beam lands on a desert, and then the desert moves. Brittle stars spiderwalk between nodules. A Dumbo octopus hovers, ear-like fins pulsing, inspecting a nodule that to her is a nursery. Sponge stalks rise like glass chandeliers, fed by currents so faint they look like thought. Each hard lump is a neighborhood. Microbes layered like cities, chemical gradients as precise as recipes, larvae tucked into pores waiting for a cue we don't hear. Meanwhile, something else is happening in the dark above. Zooplankton graze the slow snow drifting down from surface life. Micronectin, shrimps, tiny fishes, squids spend the day at depth and commute nightly towards starlight, hauling carbon down when they sink again. It's the planet's most reliable elevator. The nodules don't run that system, but they stabilize the ground floor. Disturb the base, scrape anchors, fog the water with silt, and the elevator stutters. What nobody says in investor decks is how new this knowledge is. The CCZ is Yellowstone. It's more like a library we just found the door to. Scientists are still writing the first catalog. Expeditions turn up species nobody has seen, many living only there. That's not romance, that's sampling reality at abyssal depth. When the International Union for Conservation of Nature warns that damage from mining could be permanent, they're not speculating. They're looking at growth rates measured in millimeters per million years and life histories, tied to things that don't regrow on human time. Here, S where the unknown cuts both ways. Industry says uncertainty justifies learn by doing. But uncertainty is precisely why caution exists in law. We don't know plumes spread at commercial scale, noise footprints under full fleets, or how mid-water discharge shifts food webs season to season. A University of Hawaii-led study flagged that discharge could disrupt the twilight zone, the zone that feeds everything above. That's a red light, not a yellow. You don't reroute a city's food supply to test traffic flow. And yet, the deep sea isn't fragile in the way a coral reef is fragile. It's robust in its own slow rhythm. It can handle a storm of marine snow, a whale fall, a century of calm. What it doesn't handle well is industrial continuity, machines running 24/7 over months across grids. The difference between a disturbance and a regime is scale and repetition. A single track might heal in patches. A checkerboard of harvest blocks becomes a landscape with its bones removed. Let's drop to creature level. A sponge anchored to a nodule doesn't relocate when its rock disappears. An octopus laying eggs on a firm surface can't switch to mud. Sea cucumbers that sift thin layers of sediment don't thrive under blankets. Microbes adapted to nodule chemistry can't conjure a new city on slurry. Recovery depends on hard substrate returning, and that substrate is what the business plan ships away. Now pan out. Whales don't live at 4,000 meters, but they cross above. Lanternfish school along isotherms that run like invisible highways. Tuna chase the dusk migration where bait should be. Add the projected eastward shift of big eye, skipjack, and yellowfin under warming seas into the same coordinates that hold mining leases, and you have overlap with cash flow for Pacific states. That's not a moral claim, it's a budget line. If the twilight zone thins, if bait is off schedule, tuna catches and access fees wobble. Scientists are careful. Correlation isn't causation, but management has to be conservative when the grocery store is the treasury. There's also the carbon story no one can fill. The deep ocean stores it in cold, pressure, and time. The biological pump depends on pellets sinking, on particles aggregating, on quiet layers staying quiet. Sediment plumes add fine particles that ride currents longer, keeping carbon suspended where it can be respired back to CO2. The scale of that feedback is still in journals and models, not headlines. That's the point. You don't wait for headlines to protect a system this central. Meanwhile, the ISA's own premise says the seabed beyond borders is the common heritage of humankind. Heritage isn't just metal, it's living archives, species, interactions, services we barely name. A heritage you liquidate before inventory isn't stewardship, it's a clearance sale. So what lives down there? Things with faces and things without. Animals that look like cartoons and microbes that run chemistry nobody's patented. Worlds within grains and migrations that lace the Pacific together. Known risks, habitat loss that doesn't reverse, plumes that travel beyond sight, noise that turns a soundscape into machinery, food webs thinned in the very zone that feeds the surface. Unknowns, the full cascade. Which is precisely why the smartest move is time. Time to learn without the crawler running. Time to scale what reduces demand up here, and time to resist the oldest urge in extraction. To move first and measure harm later. The scarcity story. The battery metals panic. While collectors crept across the abyss, a different machine was running on land fear. The pitch was simple. The world's going electric, metals are finite, China dominates refining, and if we don't open new frontiers now, the transition stalls. Scarcity as storyline, urgency as leverage. Get this, some of it is true. Demand for nickel, cobalt, manganese, and copper has surged with EVs, storage, and grids. Supply chains are concentrated. China refines the bulk of critical minerals and leads in battery manufacturing. Policymakers see risk in those choke points. Investors see upside in anything that promises fresh supply fast. Into that anxiety, seabed metals arrive like destiny, a new continent of resources. But look closer at how scarcity gets framed. It lumps every segment, phones, buses, grid batteries, into one giant, uniform appetite for the same metals forever. It ignores how fast chemistries shift. In the last 5 years, car makers and cell producers have pushed hard into nickel-light and nickel-free chemistries for segments that don't need 600-mile range. LFP took share without cobalt. Now sodium-ion is stepping in for entry EVs and grid storage cheap, stable, and unburdened by cobalt and nickel. China's giants have announced mass production paths. Early packs are already shipping. That doesn't erase metals demand, but it changes the slope. Meanwhile, recycling grew up while headlines chased the CCZ. First came scrap from gigafactories. Now end-of-life packs are arriving in volume. Commercial plants in Asia, Europe, and North America are recovering high shares of nickel, cobalt, and lithium from shredded black mass, then refining to battery-grade material. Targets in Europe require recycled content and rising recovery rates. Analysts model tens of billions in annual value by the 2030s and major contributions to supply, especially for cobalt and nickel. This isn't boutique, it's industry scaffolding. So why does the panic persist? Follow the incentives. New mining narratives attract capital. SPACs and growth funds prefer a frontier to a factory retrofit. Untapped metals on the seafloor sounds bigger than optimized cathode supply with recycled feedstock. And geopolitical anxiety is real. Governments want domestic supply, or at least less dependence on a single refiner. Opening the ocean becomes a sovereign impulse dressed as climate necessity. There's also a sleight of hand in the math. You'll see charts projecting metal demand through 2050 if the world electrifies everything using today's chemistries and today's recycling rates. Then the conclusion, yawning gaps only mining can fill. but change is the constant in batteries. Cycle life rises, energy density edges up, second life use expands, and recycling scales with the same S-curves that drove solar and wind. Policy accelerates it. Extended producer responsibility, recycled content mandates, design for disassembly. These turn someday into compliance. What nobody in the scarcity slide decks highlights is timing asymmetry. The riskiest period is the next decade, when EV adoption spikes and recycling feedstock is still maturing. That's the window companies use to argue for seabed mining. But that window can be bridged with a portfolio, expand refining with higher environmental standards, diversify terrestrial supply away from the most destructive routes, speed urban mining, and push cobalt and nickel-like chemistries where they fit. Every percentage point shaved off primary demand reduces the argument for opening a biome we barely understand. Meanwhile, the landmines are worse. Claim hides its own cherry-picking. Yes, laterite nickel in rainforests carries brutal carbon and biodiversity costs. Life cycle work in Indonesia pegs nickel at roughly 7.9, 4 kg of Kotwi per kg of metal just from land use change and processing choices. Cobalt in the DRC, source of roughly 3/4 of global supply, ties to abuse and corruption, especially in artisanal stream. Those impacts are unacceptable and solvable with hard governance. No-go zones, traceability, labor enforcement, and shifting demand toward lower-impact sources and chemistries. Framing the choice as rainforest devastation or abyssal plains vacuumed clean is an industry convenience, not a law of physics. There's another piece: resilience. A system dependent on a few refineries is fragile. A system that adds a new frontier with novel, poorly understood risks isn't resilient by default. Real resilience comes from diversification in chemistry, geography, and material flows. Scrap becomes stock. End of life becomes feedstock. Sodium covers use cases that don't need high energy density. That mosaic beats a single bet on a place we can't fix once broken. Scarcity, then, isn't a lie, it's a lens. It can be focused to justify whichever project sits on an investor's desk, or widen to include tools that cut demand and multiply supply paths without turning the deep ocean into an industrial district. The panic version skips the second set because it doesn't raise money as fast. The sober version asks a simpler question: do we have to gamble a million-year habitat to solve a 5 to 15-year bottleneck? Back in Kingston, brackets around precautionary aren't just legalese. They're a test of whether the scarcity story runs the room. If urgency becomes a cudgel, the crawler wins by default. If urgency becomes a design brief, we build our way out on land, in labs, and through loops without adding a plume to the twilight. The marketing machine. Green metals and lobby playbooks.